Hello everybody, today, through this video you will get to know that what is artificial intelligence. The video is generated by using NotebookLM by Google. Thank you, enjoy the video.
Today, we are diving deep into the fascinating anatomy of artificial intelligence. It's this incredibly wild journey into how we've spent a solid century trying to build machines that literally replicate our own human thought processes. And honestly, it's just as much about what that quest reveals about us as it is about the machines themselves. So, here's our roadmap for today. We're going to cover defining AI, a quick look at the history of AI, deconstructing human intelligence, some real-world applications, and finally, we'll wrap up with agents and environments. All right, let's jump right into section 1, defining artificial intelligence. What exactly is AI? To get us started, we really have to look at the father of artificial intelligence, John McCarthy. He gave us this perfect baseline definition to ground our understanding. He basically called it the science and engineering of making intelligent machines. It's essentially accomplished by studying how the human brain thinks, learns, and decides while trying to solve a problem, and then taking all of that and using it as a blueprint for developing intelligent software. Now, what's really fascinating here is that AI isn't just computer science, not even close. It is a massive intersection of multiple, totally different disciplines. We're talking biology, psychology, linguistics, and of course, math. Think about it. To create a system that truly mimics human reasoning, we literally have to borrow from absolutely every discipline that studies how we function. It's like a giant puzzle. To really wrap our heads around this, we need to contrast standard, traditional programming with AI programming. See, programming without AI is super rigid. It's specific, it answers only very specific questions, and man, if you try to modify it, you risk breaking the entire structure. But programming with AI, that's a whole different ballgame. It easily absorbs new, independent pieces of information to solve generic problems. It's quick, it's easy to modify, and it's highly adaptable. Moving on to section 2, the history of AI, a century in the making. It is wild to see how this field has evolved at just a breakneck pace. We actually start way back in 1923 with Karel Čapek's stage play RUR, which introduced the very first use of the word robot in English. Then jump to 1950, when Alan Turing introduces his famous Turing test for evaluating machine intelligence. From there, we rocket all the way up to 1997 with the Deep Blue chess program absolutely crushing the world champion Garry Kasparov. And then we land in the year 2000 with Kismet. That was an interactive robot with a face that actually expressed human emotions, which, let's be honest, is equally impressive and just a little bit terrifying. Okay, section 3, deconstructing human intelligence. What exactly are we trying to replicate? According to developmental psychologist Howard Gardner, intelligence isn't just one single monolithic thing. It's actually a massive collection of very different skills. We've got linguistic intelligence for narrators, logical mathematical for scientists, spatial intelligence for astronauts or map readers, and even bodily kinesthetic intelligence for dancers and athletes. So a machine is considered artificially intelligent when it's equipped with at least one and at most all of these varying types of intelligence. And taking that a step further, intelligence is made up of several distinct, kind of intangible components. We're talking about reasoning, whether that's inductive or deductive, learning, problem-solving, perception, and linguistic intelligence. When we sit down to build an intelligent machine, it has to be equipped with at least some of these core components, scaling from the basic perception of sensory inputs all the way up to really complex problem-solving. But hey, we've got to remember the stark contrast here. Us humans, we seamlessly perceive and recall the world using flexible patterns. We can even figure out what an object is if half of it is missing. Machines, though, operate entirely differently right now. They perceive things strictly by rules and data. They recall information using these rigid search algorithms. And if even a little bit of data is missing or distorted, they usually fail to piece together the full picture. This brings us to section 4, real-world AI applications, where AI lives today. Now, let's clear up a classic point of confusion. People use speech recognition and voice recognition interchangeably all the time, but they actually have completely different goals. Speech recognition is all about comprehending what is spoken, translating the actual words, kind of like a dictation app. Voice recognition, on the flip side, is about who is speaking. It analyzes tone and pitch as a security measure to identify a specific person. Huge difference. AI research honestly spans a massive breadth of domains in our real world. We've got natural language processing handling translations, expert systems running intense things like flight tracking, and neural networks managing pattern recognition for handwriting or faces. Then you have robotics taking care of physical industrial tasks, and fuzzy logic, which quietly runs behind the scenes in a ton of our consumer electronics and cars. You probably interact with a bunch of these domains before you even finish your morning coffee. And finally, Section 5, Agents and Environments, the anatomy of action. In AI, we call the actors agents. Basically, an agent is anything that can perceive its environment through sensors and then act upon that environment through effectors. Think about it like this. Just like you or I use our eyes and ears to perceive and our hands and legs to act, an AI agent uses cameras or infrared for its sensors and motors or actuators for its effectors. The fundamental structure of an intelligent agent is actually pretty elegant in its simplicity. It's simply the physical architecture, the literal machinery it's running on, combined with the underlying software program. It takes in a sequence of inputs, processes them through its architecture and program, and outputs a behavior. It basically just maps what it perceives directly to its actions. But here's the catch. Any machine can act randomly or just super inefficiently. So I want to ask you, what makes an agent truly rational in its environment? Well, a perfectly rational agent uses absolutely everything it has learned and perceived so far, its entire percept sequence, along with its built-in knowledge base, to always perform the right action. And the right action is just defined as the action that maximizes its performance and makes it the absolute most successful at whatever task it's doing. And guys, here is the most fascinating twist of the whole thing. For us humans, mundane tasks like walking or just having basic common sense are the easiest things in the world. We learn them practically from birth. But for AI, because those everyday tasks require immense, complex, unstructured knowledge of the real world, they are incredibly difficult. Instead, highly technical expert tasks like engineering, medical diagnosis, or formal tasks like advanced mathematics are actually way easier for an AI to learn because they rely on strict, structured rules. An AI can diagnose a rare medical condition in seconds, but it will completely and utterly fail at folding your laundry. Which leaves us with a final, thought-provoking question to chew on. If an AI can easily crush a human grandmaster at chess, but completely struggles with the basic, mundane task of safely walking down a crowded street, what does that really tell us about the true nature of intelligence? It really holds up a mirror to our own minds, showing us that human common sense is far more miraculous and complex than we ever gave it credit for. Thank you so much for joining me for this explainer. I hope this deep dive has left you eager to learn even more about the incredible anatomy of AI.